able to understand? This is q of t, this is q of t plus 1. Q of t plus 1. I am trying to fill up this. Is that clear? Right. So I will use a T flip-flop excitation table and then try to fill up this. This is already done, but I have never mentioned the word called counter. Okay, this is a new entry. Right. Can you now tell me the T flip-flop excitation table? Or try to fill up that?
Yes, ma'am.
Yeah, do that, do that. I require two, TA, TAB. So notation you can give anything. So 0, 0, T is 0. 0, 1.
0 0 0 1 0
1 is
0 0
1 0 is
then 1
similarly TV
1 1 1
0 1
1
is 1
all
1
One, 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 one.
Okay, so that means my TA and TB are ready. So TB is nothing but what? 1. Completely done, na? TB input is already known in terms of this present states, right? Whereas TA is what?
QB
What is QB, ma? I have ABs here. What is QB?
present state of B.
What? See, if at all you can check out here, it is A bar B plus A B. Oh, A bar B plus B. So what will happen? B of A plus A bar.
1.
Yeah, it's 1. So it is nothing but B. Okay. So my TA is B and TB is 1. So now let me draw the diagram. Okay, I wish to okay, no need. I can do. Now this diagram is a little tricky. So I will be using TA, it's clock pulse, PV, it's clock pulse. Okay, so TA is B. Right. So what I am getting, just a second. TB is 1. So TB is given high. 1 means high. Okay, high level. And TA is B. Okay, right. And now I am taking here also this value and this value. This is my outputs. Right. This is my A, this is my B. Real A, real B. Actually, I should write here. I'm so sorry. I should write here Q and Q bar. Okay, now hold on. Did you understand here what exactly I have done? I have drawn the sequential circuit. Now carefully understand. Here, the sequential circuit writing is very easy. Drawing is very easy. Now you tell me what is the link between these two? This is flip flop 1, this is flip flop 2. What is the link between? They are this right here is a very important trick. Please try to understand. I feel the two flip flops are disjoint. Is it so? Or they are connected together?
Yes, ma'am.
Why they are disjoint?
They are joined by clock pulse means.
Yes. So what is the trick? What is the trick? They are joined only through clock pulse. That means these two flip flops work synchronously only with the clock pulse. Right? Right? Moreover, another added point is connected to this. So it is not fair to tell that this, right? 2 points to be highlighted. Please try to understand. This is a 2-bit counter, no doubt about it. But it is called 2-bit synchronous counter. So that means something asynchronous is also lying for us. Okay, let it wait for us. So 2-bit synchronous counter, what is happening? The clock pulse is synchronizing both outputs. Right? Why? Because these two outputs will come at a time, because these two are activated by the same clock pulse. Because once I give the clock pulse, both will start working out. Right? I don't think we will have any propagation delay in this. Do you feel? Will there be any propagation delay?
No, ma'am.
Definitely not. Means not that noticeable one. Maybe because of the hardware something can be done, but we don't get. So we can extract the outputs ABs from here, which go from one state to another state, one state to another state, one state to another state. So if you want to stop the process, you have to only stop the clock pulse. That's all. So in fact, this 2-bit synchronous counter, we can just tell that it is nothing but a synchronous done by the clock pulse. If clock pulse is not existing, that means if it is removed, we can end the show. That is what it is telling. Clock pulse is the main criteria here. Right? Did you understand here what I'm trying to tell? Now, if at all I don't have T flip-flops, if at all I use JK flip-flops. Consider I'm using JK flip-flop. So I can design in a different manner, JK. If I use a T flip-flop, my design will be different. If I use SR, my design will be different. Don't you think so?
Yes, ma'am. Yes, ma'am.
So this is what a counter. Now this is a simple example of a 2-bit counter. Can we extend the same thing through a 3-bit counter? 3-bit counter means how many states we are going to get? It will start from 0, right? 1, 2, 3, 4, 5, 6, 7. Then back to 0. Right? So the counter goes on. Right? Another one more thing. Don't you think that this is a synchronous up counter because I am trying to count up? Yes or not?
Yes, ma'am.
Yes, ma'am.
Because I am going up now counting. 0, 1, 2, 3, 4, 5, 6, 7. Then afterwards 0, 1, 2, 3, 4, 5, 6, 7. So if at all I feel that starting itself, and by the way, nobody has asked the question, how we will start 0, 0? How the initial will be 0, 0? Will we place it there practically? Yes.
Ma'am, when the clock pulse is 0, then
Hmm.
both will be 0, 0.
Correct. Clock pulse is 0, both will be 0, 0. So, but we have another option in flip-flop. Only practically we will use. We can have a preset one. Preset. We can predetermine it and preset the output. Okay, that option is there. Practically when we do, we can work out. Right? Because I am showing the logic diagram only with clock pulse and T. But in fact, if somebody might have flipped your pages in your digital, you will have 2 more points. Like clock pulse, reset. No, there is a preset here, and this is called clear. Like this also they will show. What any type of flip flop. Q bar. So like this it will be preset clear. Clear means what? Because since it's a memory, they will try to ground it and then clear flush out the memory. That's what they will do. Okay, practically that is. But you need not show here. With the preset and the clear, you can avoid this. No problem. You can avoid this. Okay, so can we extend this to 3-bit? Yes, we can extend it. Right, a 3-bit counter. How many flip-flops we require for 3-bit? 0.
3.
Yes, 3. 2. 4. 5. 6. 8. Okay, with the clock pulse. Put it in a nice manner. Huh?
Your voice is not audible.